Yeah, because it's got you signed in as David. Not that it matters. Doesn't make any difference at all. But it's probably because David and I had a session last week after you, and it's going to default to the last person who signed in, probably.
Okay.
Okay.
Great.
So how's the math gone this week?
Good.
Yeah.
We had a quiz today. I think I did all right.
Okay. What stuff are you covering now? Is it different?
Yeah, we're going over lines
Okay.
again. And I had some trouble today with the standard equation.
Okay.
Yeah.
Can you verbalize problems to me, or do you need to take a
Um,
picture and send it to my email address?
no, it wasn't really that. It was just more like, here, let me get stuff out. Problems with, like, the format and which points go where and the slope and
Okay.
finding.
Why don't you read some problems to me, and we'll go over them.
All right. I don't really know if we had problems like the ones I had trouble with on the quiz today on the homework. But I can try.
Maybe you can remember something similar.
The real thing I had problems was with was problems like a line has a slope of 2 and passes through the point 4, 3 and 12, 6 or something, and then write the standard equation of the line.
Okay. That's kind of the classic algebra problem, is you give somebody slope and 1 point, and you get them to come up with the equation of the line, or you give somebody 2 points. Either one will do. It's not very common that they give you slope and 2 points, because when they give you 2 points, we can figure out slope ourselves.
Yeah.
So, but the tricky part is, let's say they give you slope and 1 point. Now, you have two ways to solve this. You can use the slope-intercept form, or you can use the point-slope form to solve it. Personally, I think point-slope is a little easier, and it is called point-slope because that's all it needs, is 1 point and 1 slope.
Okay.
Do you know the format for point? Have you had point slope? I don't want to get into it if you haven't had that format.
Yeah, we have. Isn't it
What is it?
y2 minus y1?
Close. It's y
Yeah.
minus y1. Because remember,
Okay.
we're only going to have 1 point. In other words, we're going to have this point right here. We're going to leave the y as it is.
All right. So yeah, y1 minus y1 is equal to m times, or parentheses, x minus x1.
Right. And if you ever forget this, notice that if we divide both sides by x minus x1, we end up with slope equals rise over run. So this makes perfect sense. It's just not usually memorized that way. It's usually memorized this way. And when we have the slope and 1 point, what's the next thing I can write?
After this, you can substitute in the point.
And the slope. So
Yeah.
tell me what to write.
So, y minus 3 is equal to 2 times, x minus 4.
Correct. And they may or may not accept that as a final answer. Do you know?
My teacher wanted us to put it in standard form today. Which is
Okay.
where I got tripped up, because I had the point slope,
Okay.
point slope and point intercept.
So
And then
here's the three formats. Slope-intercept, which is what?
Y equals mx plus b.
And point slope.
which is this one down here, yeah.
All right. And standard.
Yeah.
What's standard?
AX plus BY equals C.
Okay. So we want to get this in standard, which means the main thing about standard is getting your X and Y on the left and getting the numbers on the right.
Okay.
How can we do that? There's one thing we have to do to this final equation that we haven't done yet.
We'll simplify it out. But
Let's distribute that too.
yeah.
What is it?
2x minus 8.
Okay, now put it in standard.
That's where I got tricked up. I'm confused on where.
Okay, we're trying to make it look like that.
So you'd subtract the 2x from the right side and
Okay.
get 2x plus y minus 3 is equal to negative 8.
Okay, and then let's move that minus 3 over.
Yeah, add it to the negative 8, so you get negative 5.
And there's your standard format. In
Oh,
other words,
okay.
to get it into a particular format, you just have to make it look like that. You know, if they ask for it in point slope format, then this is very acceptable. That's actually point slope format. If they ask it in slope intercept format, then all I would have to do here is add 3 to both sides, and I have y equals 2x minus 5, so that's slope intercept format. So it's pretty easy to go back and forth between the 3 different formats, as long as you can remember what the general format is.
Okay. So it's just a lot of manipulating equations.
Yeah, it's a lot of algebraic manipulation of those equations to get it to look like this.
Okay.
And A, B, and C are just constants. They're numbers.
All right. Okay. And then what else was I gonna ask about today? Sorry, I have to go through my math finder. We haven't really done anything else this week besides some things on the calculator.
Mm-hmm.
And it looks like, looking forward, the next thing we're going to work on is solving using systems.
Okay, we can do some of that. Let me see if I can find, you got some problems?
Yeah, I got a few.
Okay, let's do 2 equations, 2 unknowns in each equation, and solve for the unknowns.
All right.
Okay, what's the first equation?
One of them says it's a story problem, word problem.
Okay.
So it says Melting sells half gallons of frozen yogurt for $4 each and gallons for $7.
Okay.
She sells a total of 50 containers for a total of $287.
What's the first thing, and then what are they asking, how many of each did she sell, right?
Yep, classic algebra.
What's the first step of an algebra word problem?
To define your variables.
Okay, what are we going to do?
I guess X could stand for numbers of half gallons sold.
Good.
And then
And
Y
it's
could
good, you know, it really, at least until you get really good at these, it's nice to spell the whole thing out. Or at least know in your mind that X represents the number of half gallons that we're going to sell.
Okay.
What's the second variable?
Y could be whole gallons sold.
Okay, we can do it as a 2-variable problem, but last time I think you mentioned she wanted you to do these as 1-variable problems?
Yeah, this time it's two variable problems using
Okay. Oh, because we're solving simultaneous equations. Yes, exactly. Yeah. So y is the number of 1 gallon sold. So what's one equation I can write? Based on that, what's the easiest equation to write?
Could do x or 4x plus.
Based on just the fact that 50 containers were sold. That's the easiest one to write.
Oh, x plus y equals 50.
Okay.
Duh.
We might as well get the easy one out of the way. That's equation number 1. And we need a second equation because this has an infinite amount of solutions. So the second equation is what again?
4x plus 7y equals $287.
Okay, now let's solve those two systems of equations. What two methods have you been taught for solving two equations and two unknowns?
The substitution method.
That's one. And what's
then,
the other one?
I don't remember what the other one's called.
The other one is called elimination. And it's actually the easier one to use rather than substitution. And the reason it's called the elimination method is because we can immediately eliminate one of these variables. But before we can do that, we have to massage one of these equations.
Okay.
The idea is to get one of these equations such that when it is added to the second equation, one of the variables disappears. Well, how can I do that? I can multiply the top equation by -4 every term. So -4 there, -4 there, and times -4 there. Okay, so I'm going to rewrite equation 1 down here. It's now -4x minus 4y equals -200. In other words, I'm allowed to do anything I want to that equation as long as I do it to both sides. It doesn't change anything.
All right.
So now this new equation is still equation 1. Let's get rid of that sign. Now we're going to add not this equation 1, but these two equations. Add them together.
So 3y is equal to 87?
Uh-huh.
And then you divide by 3y.
By 3.
Yeah.
Okay.
Oh, sorry, yeah.
And then how do you solve for x?
You take this y value, 29, and you put it back into your original equation.
Okay. And actually the original one that was the easiest one to put it back into is this one here. Much easier than putting it into here. So if y is 29, x is what?
1 second. X would be 21.
Okay.
Right? Yes.
And that's how we solve that. Now, we could have solved this by substitution method. Let's just go over that. To solve by the substitution method, you take one of your equations and you solve it for one of the variables. In other words, if I solve this for y, I get y equals 50 minus x, right? Now I go into this equation and substitute 50 minus x wherever I see y. So I have 4x plus 7 times 50 minus x equals 287. Now I have one equation and one variable that solves simple enough for x.
Okay.
And I get minus 3x equals minus 2 or 87. Let's see. 350, that's 50, and 13, that looks like minus 63. And then when I solve for x, I get 21. Once I've solved for x, I can solve for y the same way we did before. Just go back in and substitute it into the first equation. So that's the difference between solving by substitution and solving by elimination. And which one you use kind of depends on the way they give you the equations. In other words, if this was a word problem, like it was, the equations kind of dealt themselves. We were given equations that had x and y on the left side and a number on the right. Usually, if that's the way you have your two equations, you always want to use elimination. Okay? Only time you probably want to use substitution is, like I said, if one of the equations is given as a x equals or a y equals. Then it's really easier to use substitution and not go through the process of putting it into standard format. Because in order to use elimination, we pretty much have to get these in standard format. Okay?
Okay.
Now, let me mix this up a little bit, make it a little harder. Let's solve those two simultaneous equations. Now it's not quite as easy to get rid of a variable by multiplying one of the equations by a number.
Yeah. So for this one, would you want to do substitution?
No, I'd still use elimination, because in order to do substitution, we're going to have to solve one of these for either x or y, and that's a process in itself. There's an easier way to do it and still use elimination. I can do a couple of things. What most people wouldn't like to do, but is easy enough to do with this, is what if I multiply the top by 1.5? Makes this 3x, makes this 6y, and makes this number 15. Okay?
Okay.
So this is still equation 1. It's just been manipulated a little bit. But now I can subtract these two equations and solve for the variable. In other words, you are allowed to add or subtract equations. The last one I added because I had a negative and a positive. But this time I have a 3x and a 3x. So let's subtract the second one from the first one. And we get 0x. 6y minus 7y is minus 1y. And 15 minus 15 is 0. So I've got minus y equals 0, which tells me y is equal to 0. And then I can go back in and solve for x, just like we did before, knowing that if y is 0, x must be 5. And that works. 3 times 5 plus 0 is 15. And
Okay.
works up here also. So that's another technique to use elimination. But let me cover this and change that variable to a 5. And now that technique we just used wouldn't be very nice, because if I multiply everything by 1.5, I begin to introduce fractions. In other words, this becomes 7.5.
Yeah.
And we don't particularly want to introduce fractions. So if we can avoid fractions in solving these, we're going to be better off. Well, what can I do? How about if I multiply the top by minus 3 and the bottom by plus 2?
Okay.
Notice that's going to give me 6x here and minus 6x there. So after I do each of those, I will then be able to add the equations, which a lot of people are much more comfortable with, is always setting it up so that you're going to end up adding the equations in order to eliminate the variable. So let's rewrite 1 minus 6x minus 15y equals minus 30. Let's rewrite 2 after multiplying it by 2. And we have plus 6x plus 14y equals plus 30. Now we add them. These cross. These add to minus y equals 0. Again, we got the same solution, which obviously you should. You always are going to get the same solution. It's just there's easy and hard way to get to it.
Okay.
Okay. And I could have multiplied this top by plus 3. I didn't need to multiply it by minus 3. Notice that if I had multiplied it by plus 3, this would have been plus 6, plus 15, and plus 30. Then I wouldn't have added the two equations because adding them wouldn't get a variable to go away. But I would subtract them, and I would still get y equals 0.
Okay.
So the two things to remember is you can add or subtract these, and you can multiply each equation by whatever number you want as long as you multiply every term in it. You always have to multiply the x term, the y term, and the number.
All right.
What else you got?
No.
About another word problem. Word problems tend to give people struggles, but I think I can teach you a methodology on word problems that'll work every time, pretty much no matter what the word problem is.
Okay, so I'm trying to find the difficult ones.
Yeah.
Oh, here. With a headwind, the plane traveled 1,000 miles in 4 hours. With the same wind as a tailwind, the return trip took 3 hours and 20 minutes. Find the plane's airspeed as well as the wind speed.
What's the distance it travels on the return trip?
It does not say.
How much do you think it is?
I'm guessing it's 1,000 as well,
Yeah.
if it's going and coming from the same place.
Yeah. The only difference is that when it's going, it's into the wind, and when it's coming back, it's with a wind at its tail. So obviously its airspeed is going to be a little slower coming back than it was, going than it is coming back, and it shows up in the amount of time it took. So it took 4 hours to go 1,000 miles. So relative to the ground, how fast did it go going out?
Distance equals right down. So, okay.
So solve for R. R is rate.
Yeah, so you have 1,000 miles.
Divided by?
4.
Which gives you, yeah. What you really have is 1,000 miles, and let's check our units and make sure they are correct. We're solving for rate. Rate should be in miles per hour, and it's going to be. In other words, there's your miles per hour. That's equal to 250.
Yeah.
So first we're going to talk about ground speed. So it was 250 miles per hour going out. What is its ground speed coming back?
From the rate?
Covering the same 1,000 miles, but only taking 3 hours and 20 minutes.
So you'd have to convert that into a decimal, right?
Okay, yeah. Yeah,
So
because we
like,
can't divide this by 3 hours and 20 minutes. We can divide it by some number of hours. How much is 3?
so would it be one? So would it be 1,000 divided by 3.33?
Uh-huh. Or 3 1/3.
Yeah,
20 minutes is 1/3 hour. Okay, so that number equals,
300, right?
uh-huh,
Yeah.
so 300 miles per hour. That's how many land miles this plane is covering every hour is 300. 250 going out into the headwind. What does it want? It wants its airspeed.
Airspeed and wind speed.
What do you think its airspeed would be?
Would it be the same as the the ground speed? I mean,
If it's got its engines at the same power level.
yeah.
Because it's into a headwind, it goes slower. Its airspeed is no longer 250 miles per hour because airspeed is measured relative to the wind. But the bottom line is if it goes out at 250 miles an hour, comes back at 300 miles an hour, its airspeed is 275 miles per hour, and the wind speed is what?
270 miles an hour. Oh my gosh. Okay.
Wind speed must be 25.
Wait.
Why? Because you add airspeed and wind speed to get ground speed, and you subtract them to get ground speed when you're going the other way.
Okay.
Okay? So I got the 275 by averaging the 250 and the 300.
Okay.
And then I got the 25 because, well, I knew that going out, how did he end up only going 250 miles per hour? There must have been a 25 mile an hour wind speed working against him. So we subtract that from 275 and come up with what his ground speed was, which was 250. Coming back, the wind's helping, not hurting. So we're going to add the 25 to the 275, and that got us 300, which is the speed he did coming back.
Okay. That makes sense. So it's like the difference between. Yeah. Okay.
Primary formula is distance equals rate times time. If you start off with that, that will solve most distance, rate, time problems.
Okay. Another one?
Sure.
Let's see. Okay. An overseas phone call is charged at one rate for the first minute and a different rate for each additional minute. If a 7-minute call costs $10 and a 4-minute call costs $6.40, find each rate.
What was the second? 7-minute call cost $10. What was the second one?
4-minute call costs $6.40.
So we have an initial charge for the first minute and a second charge for each additional minute. First step of a word problem?
Define your variable.
Okay. What's X going to be?
Okay, wait. X could be the amount of minutes used per.
How about let's let that be the charge for the first minute.
Okay.
Y would be?
The charge for every additional minute.
Now we're ready to come up with some equations.
Okay.
So if a 7-minute phone call equals $10, what equation can I write? Remember that the $10, you get that from the charge for the first minute plus the charge for each additional minute times the number of each additional minute you have.
Yeah, so
the $10 how did we come up with $10?
$10 would be equal to, let's see, x plus 6y?
X plus 6y, very good.
Okay, good. That was
Yeah, because the first minute, and then there were 6 additional minutes. Okay? That alone doesn't allow us to solve anything because notice we have 2 variables, 1 equation, there's an infinite number of solutions. So the second information gives us a second equation. What's that equation going to be?
X plus 3y is equal to 640.
What's the best way to solve these 2 equations and 2 unknowns?
You could use substitution if you multiply the second, or elimination, if you multiply the second equation by a -2.
Okay. We don't always have to eliminate y. We can eliminate x also.
Alright, so you can multiply it by 1 and subtract them, or, yeah, that would work.
We don't need to multiply by anything. We can just subtract
the
second equation from the first equation. So that gives us 0, 3y, and $3.60. So y is what?
Calculator, okay. $1.20.
Okay. And what is x going to be?
Okay, so if you put that back in the first equation.
Okay. I usually put it into the easiest equation.
Okay, so the second equation.
Well, I'm not sure the second is necessarily easier. I mean, this has got a nice round $10. This has got a less round number. But the second equation has smaller numbers. So I would put it in the second equation. So x plus what?
X plus $3.60.
Good. You shouldn't have had to remultiply that. In other words, we knew what 3y was. 3y was $3.60. And that's equal to 640. So what is x equal to?
$2.80.
Yeah. So there's our answers to the problem. The charge for the first minute is $2.80. Each additional minute is $1.20. See how once you've defined your variable, the equations kind of do themselves. I mean, coming up with the equations is pretty easy. Solving them is pretty easy. The greatest difficulty of word problems is this step right here. But usually all you have to do is look to the last sentence. In other words, what was the last sentence of that question?
Find each rate. If a 7-minute call, yeah.
Find each rate. So x is the rate for the first minute, y is the rate for the second, each additional minute. In other words, it's easy to figure out how to define your variables. Just look to that last sentence. Now that won't work in 100% of word problems, but it'll work in 95% of word problems, where the last question they ask is the variables that you're looking for.
Okay. Yeah, okay. That one wasn't so bad. Oh, geometry one, okay.
Okay.
Two isosceles triangles have the same base length.
Okay.
If the legs of one of the triangles are twice as long as the legs of the other, find the lengths of the side of the triangles if their perimeters are 23 centimeters and 41 centimeters.
I'm sorry, the numbers again. 41
23 centimeters
and 41.
yeah, and 41 centimeters.
Now I'm going to have to draw the second one down here. Is that a reasonable picture? We know the base length is the same, and these sides are going to have to be closer to the base length in order to give it a smaller perimeter, right?
Mm-hmm.
In other words, the greater angle that these are right here, in other words, if I want to draw that first triangle as something that looks like this, that's a bigger perimeter still. So let's draw it. No, it doesn't matter how we draw it. This is an algebra problem more than a geometry problem. So this is the base length. We'll call this side 1. What should we call this one over here? In fact, let's call this X.
Okay.
Let's call this Y. What's this side over here?
X also, because it's isosceles.
And this side is Y.
Yeah.
So 41 is equal to what?
41 is equal to 2y.
Up here.
Oh, sorry, it's equal to 2x.
Okay. Plus B. Okay. In this picture down here, what equation do I get?
You get 23 is equal to 2y plus b.
What was the other piece of information that I didn't write down?
That the legs of one triangle are twice as long as the legs of the other.
So that translates to X equals 2Y, correct?
Yeah.
Okay. So there's a third equation. X equals 2Y. Now notice we have 3 equations and 3 unknowns. Their question is, what is the base and what are the dimensions of both triangles? They want to solve for X, Y, and Z, or X, Y, and B.
Their question is, find the lengths of the sides of the triangles.
Okay, so the only thing we have to solve for X and Y.
Yeah.
Okay.
So
now we can use substitution because we have one equation completely defined as a variable. In other words, this is not in standard format. So it makes it less easy to use elimination because we would have to manipulate this to get it into standard format. So we'll use substitution for this one. So wherever I have X, I'm going to substitute 2Y.
okay.
So let's rewrite equation number 1.
So 4y plus b is equal to 41.
Now let's deal with new equation 1 and old equation 2. Let's eliminate the b and solve for y.
Okay. Could you add them? You can't do that, correct?
That doesn't eliminate the b. If you want to add them,
We'll subtract them.
well, you can subtract them. That'll work. A lot of people are not comfortable with subtraction. So a better strategy, I don't know what you are, if you're comfortable with subtraction or not. If you have any discomfort with subtraction, then it's better to multiply one of these equations by a -1, changing the sign of every term.
Okay.
Okay, let's do that. Let me take equation 2 and multiply it by a -1. Now we can add the two bottom equations and the b will go away. And we'll be dealing with all positive numbers. So not only did we eliminate the problem of subtracting one equation from another, which will cause mistakes, but we're dealing with all positive numbers now, not negative numbers. We're now going to add both of these equations. B goes away. Y equals 9. What is x equal to?
X would be equal, well, okay, wait, x is equal to 2y, so if y is 9, x is 18.
And there's your answers.
Perfect, okay. So you can use, like, down here, like we did earlier, you can use substitution and elimination.
Yeah, like we just did in that problem. We started out by using substitution because we actually had 3 equations and 3 variables. And so to solve for the other 2, we needed to somehow eliminate. The first thing we really eliminated was the x variable by using 2y instead of x. And then we were able to eliminate the b variable and solve for y and then go backwards. So once you get one of the variables, it's easy to get the others. But yeah, that was a little tricky. Yeah, absolutely. All of these techniques all produce the same answer, so they can definitely be used in conjunction with one another. Solving 3 equations and 3 variables all by elimination can be a little tricky. That's probably something you're not going to get for a while. I would say that would be more of a mid-semester problem. Where, you know, you have x plus y plus z equals 10, and then you have 2x minus y plus 3z equals 5, and then you have an x minus y plus 2z equals 2. There's 3 equations and 3 variables, and it can be solved by elimination, but much harder. You take 2 of these and produce a 4th equation, take the other 2, produce a 5th equation, and then you solve equations 4 and 5 like it was 2 variables only, and then work your way backwards. So it becomes increasingly difficult as you add variables. But the last one wasn't hard for us because one of the equations was so simple. It was x equal 2y, that we were immediately able to substitute that and narrow the problem down to 2 equations and 2 variables. Always remember you got to have the same amount of both in order to solve it. And they got to be independent. In other words, if I give you this equation, and then I say, well, I know you can't solve that for x and y, but let me give you a second equation. Is this going to help us solve it?
Yes, because
Well,
you can...
Okay, let's try it. Let's see what happens. What do you got to do? What do you got to do to the top equation?
I lied. You can multiply it by a -2.
So we get minus 4x minus 6y equals minus 10, right?
Yes.
Now add both of those equations. What do you get?
0 plus 0 is equal to 0.
So the reason that it didn't work is because notice the second equation is merely the first equation times 2. So you can't just have any 2 equations to solve. They have to be independent from one another. And these are not. This one is merely a multiple of 2 of the first one, so it doesn't really add anything at all. So it's solving with this one is exactly the same as trying to solve the whole thing from one equation only. And like I said, there are an infinite number of solutions there. I mean, x could be 1, y could be 1. X could be 1/2, y could be something else, and there are literally an infinite number of solutions for x and y if you only have one equation.
Okay.
All of these word problems we've been dealing with, the word problems give you the second equation, and it's independent of the first. It's not always easy to tell if equations are independent of one another, but at your level algebra, dependency will always be just a straight multiple. So just always look for a multiple. If one equation can be arrived at by multiplying the other equation by a constant, you know it's not independent.
All right. Could it be also like with, like I know when you're solving with inequalities, you can get something like 5 is less than or equal to 4, and then since that's not correct, could you also get like the no solution, no actual solution?
Yes, I'm glad you brought that up. That's a good point. To get no solution, which is a possibility sometimes. Let's see, if I make my second equation, trying to figure out what I need here to get no solution. You're right. There can be 2 equations and 2 unknowns that don't have a solution, and the way you get it is when you end up solving it the way we typically do, you get 2 equals 4, or you get 0 equals 3. So whenever you come up with a solution like that, you know that there is no solution to this problem. I can't off the top of my head think of how we can do that.
But it's the same concept, right? Like you end up with 3 is equal to 2 or something?
Yes.
And it's...
Yes. In other words, here's the deal. When you have 2 equations and 2 unknowns, you either have one solution, which is the case most of the time. You have an infinite number of solutions, which was the case when I merely had one equation and a multiple of that equation. Or you can have no solutions. Those are the 3 possibilities. This is the one you deal with 95% of the time. This one is only going to come up on trick questions on the SAT and the ACT. And this one might come up on questions on the ACT also, or the SAT. These 2 are rarer, but it is true when you have 2 variables and 2 equations, you do have 3 possible results. You don't always get a unique single solution.
Okay.
Oh, I know how to do this. Yeah, how about if we did this? There you go. There's 2 equations. X plus y equals 2 and x plus y equals 5. Notice that if we subtract one from the other, we get 0 equals minus 3. Well, that tells us that these 2 equations do not have a solution. There is no set of values, x and y, such that that would be true and that would be true at the same time. Impossible. Okay? So I think that covers the situation you were talking about.
Okay.
Your audio's breaking up a little bit. I didn't catch that last thing. Still there, Sarah?
Yeah, I'm having trouble like connecting. It's getting better though. It's working on it.
Okay.
Okay, there you go.
Usually, when you're running GoToMeeting, you probably need to close out most anything else that you're running on your start bar.
Yeah, all the other programs are closed. It's just
Okay. I find that GoToMeeting is a real power hog. It uses all the resources it can get. And that if I have anything else running at all, it makes it difficult on my end. I'm not sure if your end is quite that way because I'm actually running a different version. I'm running the hosting a meeting, and you're running joining a meeting. So might be not quite as bad on your end. But sometimes, like if I try to turn on my camera, it'll balk. It won't like it because it takes too much resources.
yeah. I think this one's similar. This computer gets incredibly angry if you have more than 2 programs open at the same time. So
let me briefly show you how to see a recorded session.
okay.
Go to the website, and you want to get it so that click on any of these links and you'll get that ID number. I believe your ID number was 91. Yeah. I'm putting both you and your brother's recordings on the same page. I hope that's okay. If it isn't, I can change that, but I figured it wouldn't matter. So you'll notice last week there's his. Here's yours. If I click on this play, it'll play yours. Word problems?
Yeah, okay.
Notice that it's just like any YouTube video. You can fast forward it. Maybe you understood everything but the last 10 minutes. Take it up to that last 10 minutes, play it from that, you can get a nice review. So, I don't know if those will come in handy for you or not. I just wanted to show you how to get there. If you like, let me copy and paste this into the GoToMeeting. If you look at your GoToMeeting panel, you should see that link. You see it in the chat window? Your chat window, you may need to press the plus sign in front of it to open it up.
Okay.
Now click on that link and it'll take you straight to this page, and then you can save it.
All right. So, oh, the computer's breaking up again. All right.
Okay. Why don't we call it a session, and I'll be back online in 4 minutes for your brother David.
All right. Thank you.
You're welcome, Sarah. I'll talk to you next week.
All right. See you next week. Bye.
Bye-bye.